Hello everyone, welcome to our channel Chemistry Academy. This is the Boron family part 3 in inorganic chemistry for IIT JEE. So let us start compounds of boron. So in this series we are going to discuss about these compounds of boron. One is borax, the second is boron nitride, the third is boric acid, then colemanite. This is the beautiful structure, crystalline structure of colemanite, and we are going to discuss about diborane. So today our focus is borax and diborane. So we are starting with borax, right? So it is usually written as Na2B4O7.10H2O, but actually it is made from two tetrahedral and two triangular units joined. It has 8 water of crystallization. So this is a powdered form, or this is the borax. It is a crystal, small crystals. It look like a soft snow like thing. So this is the crystal of borax, and the formula of borax is Na2B4O7.10H2O, but it's very simple to remember it. So how we'll remember it? There are 4 boron atoms, right? So there are 2 positive charge because 2 Na plus ions are there. So the anion part has 2 boron atoms in minus 1 oxidation. They have 1 negative charge, you can see over here, right? So there are 4 boron atoms and there are 5 BOB bond. There are 5 BOB bond and there are 4 OH group attached to each boron atom. So from here you can find out that the water molecule will be 2. If I remove this as water molecule, I can write 2. If I remove 2 water molecules, I can write Na2B4O7. So most of the time this boron is written as Na2B4O7. And if we consider water of crystallization, I can write that total 10 was there. Now 2 are inside. So I can write here that there are 8 water of crystallization. So you can write borax as Na2B4, and here 5 oxygen atoms are there. When 2 water molecule will remove, only 2 oxygen atoms will left, so we'll write Na2B4O7. So most of the time the reaction of borax is taking place at a higher temperature. So in place of this actual structure, we do write this one. So it is we should understand that why we are writing Na2B4O7. Borax solution is an acidic buffer solution. It is a mixture of weak acid and its salt with a strong base. 5 molecules of water is required to hydrolyze 1 formula unit of borax. So when we are discussing about this borax, I can write now the logical formula of borax is Na2B4O5OH4 dot 8 H2O in solid state. When this borax is added to water, it will dissolve in water. So after dissolution in water, it will exist like Na2B4O5OH4 in aqueous state. Now this anion of borax is going to react with water, which is known as hydrolysis. So this is the structure of anion. So there are 2 boron atoms in minus 1 oxidation state. This is the 2 tetrahedral unit and this is the 2 triangular unit. So what will happen that when there is hydrolysis of this anion of borax, then water molecule will added here and water molecule will be symmetrically distributed. So on one side OH will be added and the other side H will be added. Same way there are 5 BOB bonds. So if I add here OH group symmetrically, if I break water and if I add here H and OH, again if I break this bond here it will be H, then here it will be OH, and here if it is H, then this will be OH. So now you can see that after hydrolysis there is formation of 2 molecules of boric acid. Those boron atoms which do not carry any charge is triangular unit, so that is converted into boric acid, and the other sp3 hybridized boron atoms is converted into BOH4 minus tetrahedral unit. So we should understand that when we are writing this, it means that the meaning of this is there is 2 molecules of boric acid in aqueous state. So borax solution means 2 molecules of boric acid plus 2 molecules of salt of boric acid with a strong base, that we can write NaBOH4. So Na plus and BOH4 minus. We know that boric acid is not a protic acid, it is a Lewis acid, so it is accepting OH minus. So when NaOH will react with boric acid, it will form NaBOH4. So this is weak acid and this is its salt with a strong base, or we can say weak acid and conjugate base. So from here, we can say that this solution is acting like a buffer solution. And the pKa of boric acid is 9.26. So it is an acidic buffer solution. So if I write what is the pH of this buffer solution, pH of buffer solution is pKa plus log concentration of acid in the denominator, that is BOH whole thrice, upon concentration of its conjugate base, so that is BOH4 minus, and both are in equal amounts. So this is log 1. Log 1 will be 0. So we can say that this is equal to 0. pH is equal to pKa. And the value of pKa, boric acid is a very weak acid. pKa value is given 9.26. So we can say that borax solution is alkaline in nature. Right? Litmus paper, it can turn litmus paper blue because it is alkaline in nature. So hope you understand that 5 water molecules is required because there are 5 BOB bond. And after hydrolysis, there is formation of 2 triangular units and 2 tetrahedral units. So this solution is acting like a buffer solution. Third point, borax is used as a primary standard for titrating acid. So primary standard means borax, if you keep it is not reactive in nature, it is not hygroscopic in nature, its solution concentration will not change with time. If you make a solution of borax, its solution concentration is not going to, it is not reactive in nature, right? So it is not going to react with atmospheric things and all that. So now if I have to standardize HCl solution, most of the time the things or the solution which we have to standardize generally present in the conical flask, but it is not always true. Like here, borax is a standard solution. We know the concentration of borax. So we put a particular amount of borax and we make a solution whose concentration is known. And this HCl solution, because HCl is volatile in nature, so HCl is a gas at room temperature. So when we make a solution, and if we open HCl, some molecules of HCl will go outside. So because of that, before using HCl for any titration, we have to find the exact concentration of HCl. So this is present in burette. So when this titration is going on, this titration is going on in presence of indicator, and that indicator is methyl orange. Methyl orange is the indicator, and we know that what is the pH range for methyl orange, that is 3.1 to 4.4. Between this pH range, methyl orange will not show any particular color, but if the pH is less than 3.1, it should be acidic medium and it is red in color. And if 4.4 pH is greater than 4.4 or more, relative basic medium, and it has yellow in color. So initially it is orange in color because we know borax means pH is 9.26. So when pH is 9.26, it will be orange in color, and it will convert to red color at the end point, because when this titration is over and few drops of HCl is added, then pH, because of this strong acid, generally lies between 1 to 3. So near about 3, jaise ye near about 3 aayega, then what will happen, that this methyl orange from yellow converted into red, and as soon the color will change, we'll stop adding HCl. So we know that what is the volume of HCl in this titration. We know what is the millimoles or milliequivalents of borax. From there, we'll find out what is the molarity of HCl. So for standardizing HCl solution or sulfuric acid solution, we are using borax. On adding HCl, it will react with, so what is the reaction taking place we are discussing, because we know that borax solution means it is a solution of boric acid and NaBOH4. Acid and acid is not going to react. When I will add HCl into this solution, boric acid is not going to react with HCl. So on adding HCl, it will react with NaBOH4, and HCl displaced weak acid, that is boric acid, at the end point. Solution contains weak acid. So this is the reaction which is taking place. This is NaBOH4 minus. So Na plus is a spectator ion. I can write in this form. And it is reacting with HCl to form boric acid, water, and Cl minus. Or I can write like this. Or sometimes this water molecule from this, because generally these reactions are taking place at high temperature. So if I remove, I can write this as metaboric borate, sodium metaborate, NaBO2. If I remove two water molecule from here, two oxygen atoms will go and I can write NaBO2. So sometimes this reaction is written like this. NaBO2 is reacting with HCl to form HBO2, that is metaboric acid, and there is formation of NaCl. So if the reaction is taking place at higher temperature, we can write the reaction like this also, right? Fourth point, borax is used in borax bead test for identification of basic radicals. So this is a very important test. Borax bead test will study in salt analysis, but here there is an introduction of that. So Na2B4O5OH4 dot at H2O, 8 is the water of crystallization. So when we heat this strongly, all the hydrogen atoms and oxygen, some of the oxygen atoms will combine in the form of water molecule and go outside the system. That's why on sometimes this borax is not written like this, it is written like this, right? So when reaction is taking place at higher temperature, it can be represented as Na2B4O7. Now in this Na2B4O7, we know that it is made up of NaBO2 and B2O3, right? So what is happening that on heating borax, it will finally convert into sodium metaborate and boron sesquioxide, B2O3. So we know that we should understand here that we are saying that this borax is nothing but it is a mixture of two molecules of boric acid, BOH whole thrice. So we know that on heating boric acid, what will happen? On heating boric acid, there is formation of B2O3 and the water molecules will eliminate. So here we can say that three water molecules will go in the form of gas and this solid remains, right? It is a colorless glassy solid B2O3. Same way I can say that in this solution there is Na, two molecules of NaBOH4. So if I am heating this, there is formation of two molecules of NaBO2 by removal of water molecule. We can say that when four water molecules will be removed in the form of gas, this will be formed. So you can understand the product that this is two times of NaBO2, sodium metaborate, and B2O3. This is a acidic oxide. Now these two when combined, they will form a glassy bead, transparent bead, right? So this is a transparent glass like of substance. Borax bead test is applicable only to colored salt. In borax bead test, colored salts are decomposed to give colored metal metaborates. So we have taken one example of cobalt 2 plus. So what we'll do that we have a salt and we want to test this salt, and the salt is containing cobalt oxide, right? So this compound is cobalt oxide, and we can only test those salts which are colored. We cannot borax bead test for zinc because zinc compounds are colorless. So colored compounds like transition metal compounds, right? Cobalt, nickel, chromium, copper, like that. So here we are discussing about that. We have a bead right here. What is happening that when we are heating this borax at higher temperature, we got a bead, right? So this bead is present in that platinum wire, this ring, right? Here bead is there, and we take this bead in this flame, and there are two flames here. This outermost where oxygen is easily available is known as oxidizing flame, and this inner one is known as reducing flame. So what we'll do that we'll heat this bead, glassy bead, for a definite amount of time in oxidizing flame and reducing flame separately. So what is happening, suppose I am heating in oxidizing flame this B2O3, and then I will take a very small tinge of a small amount of this testing salt, and after mixing these two, again I will put on this on oxidizing flame. So what will happen that this metal oxide will dissolve, it will react, we can say that, with this B2O3 or that bead part, depending upon the compound, right? Like here, if I'm saying cobalt oxide, then cobalt oxide is going to react with this B2O3. Here, when it is chromium oxide, it is going to react with NaBO2. So what is happening that again, after mixing this salt and this bead, for very small amount of salt is taken, and then we'll again heat in this oxidizing flame. After some time, a color will appear. So in oxidizing flame, the color will be different, and in reducing flame, the color will be different. So I have taken only those examples which are very important and they are less confusing. For cobalt plus 2 in oxidizing flame as well as reducing flame, the color will be same, that is blue. You can remember that cobalt plus 2 oxidizing and reducing in both flames, the color is blue. And for chromium plus 3, it's green in both flames. For other salts, the color is different in different type of oxidizing and reducing flame. At least you should remember these two, which are very important, and these things are asked in JEE Advanced. So this is about borax bead test. So what is happening here, that this cobalt oxide will react with B2O3 and it will form this compound, and this, because cobalt is colored, so because of that, inside the bead the color of this will appear, so that's why the bead becomes blue in color. Same way for chromium, it will become green in color. So this is about the borax bead test. The fourth is preparation of borax. So borax can be prepared from colemanite by boiling it with concentrated solution of Na2CO3 and CaCO3 is filtered off. So this is the reaction, right? Most of the time we'll write borax as Na2B4O7 in place of Na2B4O7.10H2. We should have the feeling that why we are doing that, right? So we'll discuss about that. So this is colemanite, and colemanite is reacted with Na2CO3 solution, and this reaction is taking place at higher temperature. We are boiling these two in the same solution, and there is a formation of precipitate of calcium carbonate and borax is formed. Along with borax, there is sodium metaborate. So now let us try to understand that how these things are taking place. So we know that this is colemanite, Ca2B6O11.5H2. This is the formula like Na2B4O7.10H2O. Here it is Ca2B6O11.5H2. This is also very logical. There are calcium atoms. So I will say that there are 4 boron atoms which has negative charge. So there are 4 tetrahedral unit, and the remaining 2 will be the triangular unit. So we in colemanite there are 4 tetrahedral unit and 4 tetrahedral and 2 triangular units, right? So again here, if we draw the structure of this, these 2 calcium atoms are there. There are 4 boron atoms which has negative charge, right? So those boron atoms which has negative charge has tetrahedral units because they are making 4 bonds. And there are 2 which are triangular units, like this is a triangular unit and this is a triangular unit. So what is happening that when I am writing the formula, the actual formula is this. There is 6 boron atoms. So like benzene, I am placing that this is 6 boron atoms, and these boron atoms are connected by BOB bonds. So in between you can make 6, and since there are 4 positive charge, 4 boron atom has negative charge, so we have to connect 4 boron atoms together. So here with oxygen these 2, and here with oxygen these 2, right? So already 6 were there and there are 2, so there are oxygen atom in between is 8, right? BOB bond, this oxygen is related to that, that is 8. BOB bond is 8. So if they are asking that how much water molecules is required to hydrolyze one molecule of colemanite, I can say that BOB bond is 8 in number, so the water molecules required will be 8, like that. In borax, we are saying that BOB bond are 5. So 5 water molecules are required to break those bonds. Same way here we can also, and we don't have to remember. If I know the formula, logically I can find out that how much water of crystallization is there, because 6 boron atoms means 6 OH group, means if I try to make some water molecule from this, I can make 3 water molecules, right? Because 6 hydrogen atoms are there. So total we have written that 5 water molecules. So 3 water molecule is inside. It means that it has water of crystallization of 2. So this is also a fixed question. With the logic, you can predict that what is the water of crystallization after a very long time. Also, if you remember the formula of colemanite, or question if it is given that what is the formula of colemanite, there is no need of mugging. With logic, you will able to find what is the water of crystallization. So again here, what is happening that when this colemanite, which is existing in this form of solid, is added to water, actually in water it exists in this form, 2 times of calcium 2 plus ion, and after hydrolysis there is 2 molecules of boric acid and 4 molecules of salt of boric acid, right? So this is tetrahedral unit, like 4 boron atoms with negative charge, they are converted into this. So it is also a buffer solution, right? And pH of this buffer solution will be what? pKa plus log 2, because this is in numerator 4 and this is in denominator 2, so log 2 will come. So pKa plus log 2, right? So it is also a buffer solution. Now what is happening here, that when we are adding this colemanite into water, it exists in this form, and now in the solution Na2CO3 is there, so Na plus ion and CO3 ion is there, so CO3 and calcium 2 plus, because it is sparingly soluble, they will combine to form the precipitate. So we are talking about this precipitate will form. Now we can see here that in the solution we have, because there is formation of 2 molecules of calcium carbonate, because here 2 calcium 2 plus ion there, so 4 Na plus ion will be there because of this Na2CO3. So among these 4 Na plus ion, you can understand that 2 molecules of boric acid and 4 BOH4 minus units are there. So 4 and 4, these will form 4 NaBOH4 minus, or at higher temperature, if I remove water molecule, they are equivalent to 4 NaBO2 units. And this boric acid, 2 molecules of boric acid can be written as B2O3. So now if I combine, if we see at higher temperature, if we do not want to think about water or OH group, you can see here that boric acid 2 molecules is equivalent to B2O3, and this 4 molecules of NaBOH4 minus can be written as 4 molecules of NaBO2. So among these 4, these 2 will combine with this to form Na2B4O7, right? ये borax बना लेगा, तो यहाँ borax है, and the remaining 2 you can see over here. So very logically I have explained that why this reaction is taking place. So this is the first reaction. Borax is prepared by colemanite by boiling it with concentrated of Na2CO3, and there is a formation of CaCO3 which is filtered off. So after filtration, these 2 compounds will be left in the solution. One is borax and the other is NaBO2. So sodium metaborate left in the mother liquor. So what we can do that by, because this borax can be crystallized, right? It has less solubility, or its solubility depends on temperature. So on cooling, this will crystallize out. So I can remove this. So the mother liquor means the initial solution, because we have started with this solution and then we are adding. So after the reaction, this is precipitate out and this can be crystallized out. So this is left finally, right? So this is mother liquor, means the initial amount of the liquid we have taken, in that NaBO2 is there. So sodium metaborate left in the mother liquor. When CO2 gas is passed to the mother liquor, borax is again formed, which is crystallized. So I have written this reaction first. So now you can say that this NaBO2, and I am writing in simplified form because otherwise it is complicated. I will explain that. NaBO2 plus CO2, right? There is formation of borax and Na2CO3. So most of you will convince that, okay, Na and CO2 is there, Na2CO3 is there, but you will not able to find out how this is formed. So I'm explaining that in the solution, right? So this NaBOH4, this means this, right? It is equivalent to this, and there are 4 molecules of NaBOH4 if I am taking, and from, suppose in these 4 molecules, 2 molecules are reacting with carbonic acid. CO2 in water means carbonic acid, and pKa1 for carbonic acid is 10 to the power minus 7, and boric acid का जो pKa है वो 9.26 है. So I can say that carbonic acid is a stronger acid than boric acid. So strong acid will displace weak acid. So what is happening here? there is a formation of boric acid, right? So this is happening. Now pKa1 is this, but pKa2 for carbonic acid is 10 to the power minus 11. So this I have written initially NaHCO3 कि एक ही H plus देगा क्योंकि दूसरा जो है वो weak है इससे, so it cannot displace. So that's why I'm writing NaHCO3. But this is reaction is taking place at higher temperature, boiling water. So what will happen that this NaHCO3 on boiling will decompose to give Na2CO3 H2 and CO2. So that's why the product is Na2CO3. Now you can understand that by this reaction, CO2 react with this to form boric acid, and this boric acid and some molecule of NaBOH4, they will combine to form borax. If I write in simplified form, it will be Na2B4O7. So hopefully you understand that how this reaction is taking place. Among these four molecules, two molecules of NaBO2 is reacting with CO2 to form two molecules of boric acid, and the remaining two molecules of NaBO2 and boric acid will form borax. Right, so this is the reaction in JEE Advanced. Many years ago, they have asked this question. Fifth reaction is reaction of borax with acid, right? So it's very simple reaction. We are taking a strong acid. We know now that borax is a mixture of weak acid, boric acid. There are in one molecule or 1 mole of borax, there is 2 moles of boric acid and 2 moles of salt of boric acid with a strong base. So here acid and acid is not going to react. So what is happening here that this is a strong acid and it is displacing this weak acid from this salt. So that is the reaction. So if I write logically, ये reaction होनी चाहिए, तो क्या है कि इसके एक मॉलिक्यूल में बोरिक एसिड के 2 मॉलिक्यूल हैं और 2 मॉलिक्यूल इसके हैं, तो इसके 2 मॉलिक्यूल से 2 मॉलिक्यूल HCl के रिएक्ट कर रहे हैं, and there is formation of 2 moles of NaCl here and 2 molecules of boric acid because it is giving H plus and it is releasing OH minus. H plus and OH minus will, because this is BOH4 minus, right? So OH minus and H plus will form water molecule, right? So 2 water molecule here. So 2 molecules of boric acid, पहले से ही 2 थे और इस reaction से 2 और बने. So there is formation of 4 molecules of boric acid and 2 molecules of NaCl and 2 molecules of water. Now you know that boric acid is at low temperature, it is less soluble, it will crystallize out. So if I cool, this crystal will form. Same way I can say that H2SO4 can react with borax to form boric acid, Na2SO4 and water, same reaction it is. So concept here is that reaction of borax with a strong acid means a strong acid will displace weak acid. So in questions they will say that on titrating this salt solution with acid, strong acid, there is formation of a crystal because boric acid at low temperature is insoluble in water. It is soluble when we increase the temperature of water. In warm water, boric acid is more soluble, right? In cold water, boric acid is less soluble. So crystal of boric acid will obtain. That is very common line of questions. So whatever we have studied, we'll try to revise this. Okay. So the first example is a certain salt X gives the following test. So first point is its aqueous solution is alkaline to litmus. So it is satisfying the condition of borax because we have studied that borax solution is acting like a acidic buffer and pH of the solution is pKa of boric acid and pKa of boric acid is 9.26. But by reading this line, I cannot justify the whole thing. I'm just explaining that this is matching with borax. On a strong heating, it swells to give glassy beads. So you know that any substance like if we say that CuSO4.5H2O is there, if you heat it will swells because when the gases will, when water molecule will go outside from the solid, they will make pores inside the solid and it will become it swells up, right? So anything which on heating releasing gases, that is the property that it will swells, right? So here we know that when borax is heating, water molecules are going outside and we are getting NaBO2 and B2O3 bead test mein, right? So that's why this swelling is there because water molecules will go away. When concentrated sulfuric acid is added to a hot concentrated solution of X, white crystals separate out. So again, we have discussed that because of that reaction, a strong acid will displace weak acid. And boric acid, when it is cooled down, it will crystallize out, right? So crystal separate out means boric acid. Identify X and write down the chemical reaction in step 1, 2, and 3. So let us revise this. So I can say that the X will be borax, and the formula of borax we can write in two form. I can write that borax is Na2B4O7.10H2O. And why we are writing Na2B4O7, we should understand. Actual structure is Na2. There are 4 boron atoms and 5 BOB bond, and with each boron atom there are 4 OH group. 1 OH group with each boron atom. So from here, 2 water molecules you can see, right? So here water of crystallization will be 8. Or we can say that on heating, if I heat, what I can write that Na2B4, 5 ऑक्सीजन एटम यहाँ है, यहाँ से जब 2 वाटर मॉलिक्यूल निकल जाएंगे तो 2 ऑक्सीजन एटम बचेंगे, तो 5 + 2 will be 7. So that's why we are writing in this form Na2B4O7. So now we know about the X. The first point is its aqueous solution is alkaline to litmus, so that I am explaining that it is a buffer solution, right? So pH is equal to pKa plus log millimoles of acid or concentration of acid. The acid is boric acid, and its conjugate base, that is BOH4 minus, and both have the same concentration. So I can say that pH is equal to pKa. For boric acid, pKa is equal to 9.26. So this is alkaline to litmus paper. First point we have done. The second point, on strong heating, we already know that on heating this, I can start with Na2B4O7.10H2O. So first on heating, it will loses all the water molecules. So I can write, after losing, I can write it is Na2B4O7. And on strong heating, about 740 degrees Celsius, if you heat this, then there is formation of NaBO2. There are formation of 2 units of NaBO2 and 1 unit of B2O3. And when they are combined, they will exist like a bead, right? So they will form beads. So that's why this is important. So the mixture of this will be bead. Now the third point, when concentrated H2SO4 is added to hot concentrated solution of X, white crystal separate out, so that we can understand. I am writing for solution. So if you understand the concept better, this water of crystallization will dissolve. So I can write that it is existing in the form of Na2. I can also write Na2B4O7, right? And then we'll react with sulfuric acid. We can write like this, or this is the more logical way to write, because it is existing like this. In the solution, it is acting like a buffer solution. So only this salt is going to react with this. So NaBOH4 in aqueous state will react with sulfuric acid. So 2 molecules of this react with 1 molecule of sulfuric acid in aqueous state. And there is formation of Na2SO4 plus boric acid, 2 molecules of boric acid, BOH whole thrice, plus this will give 1 OH minus, and this will give 1 H plus, 2 H plus and 2 OH minus. So there is formation of 2 water molecules. This is a logical way to explain that. Already 2 boric acid molecules are there, because here it is borax. If I combine these two, this is borax, BOH, but boric acid is not reacting. So what is happening, that finally in the solution, there are 4 molecules of boric acid, which will form corresponding to 1 molecule of borax on reacting with strong acid. So these are the reaction taking place. Another example, a white precipitate B is formed when a mineral A is boiled with Na2CO3 solution. The precipitate is filtered, and the filtrate contains 2 compounds C and D. The compound C is removed by crystallization, and when CO2 is passed through the mother liquor, left D changes to C. The compound C on strong heating gives 2 compounds D and E. E on heating with cobalt oxide produce a blue colored substance F. Identify A to F and give chemical reactions for the step 1, 2, 3, and 4. Okay. So first thing I want to write here that white precipitate B is formed when a mineral A is boiled. So the mineral A is colemanite, and colemanite is Ca2 B6. I'm writing logically. So there are 8 BOB bonds, and there will be 6 OH groups attached to each boron atom. After this, we can see that there is only 2 water of crystallization left. So this is the very logical structural way to write this. Otherwise, I can say that this A compound is Ca2B6O11.5H2O. And sometimes in reaction, in place of 5H2O, we can only write that Ca2B6O11 only, and that we should understand here, because if I remove 3 water molecule from here, 3 oxygen atom will be left. So 8 plus 3 will be 11. So you should understand all these things, right? So this is about compound A, that is colemanite. And compound B will be calcium carbonate. So let me write the reaction. Now I am going to write the reaction number 1. So this is the compounds involved in the first part of the question. So let me write here. Again, I am writing that what is the reaction taking place. Ca2B6O11 I am writing, and now you can understand that writing in this form will be more easy. So Ca2B6O11 is reacting with Na2CO3, and because of that there is formation of 2 molecules of calcium carbonate, because 2 calcium ions are there. So 2 molecules of Na2CO3 will be required. Now we can understand that Ca2B6O11 in aqueous medium exists in 2 molecules of boric acid and 4 molecules of that tetrahedral unit, right? So 2 molecules of boric acid and 4 molecules of tetrahedral unit will combine to form borax, right? So I can write here that there is a formation of Na2B4O7. And among those 4 tetrahedral units, only 2 units will left. So I can write that along with NaBO2. So here I am not writing hydrogen and oxygen, that water molecule I have removed because the reaction is taking place at higher temperature. Writing by this way is more easy. That's why we are writing in this way, right? So this is the reaction taking place. I think that the reaction is balanced now. Yes, the reaction is balanced. Boron atoms is 6 in number. Boron atoms are 6 on the left hand side. Sodium are 4. Sodium are 4. And this is the balanced reaction. This is about the reaction number 1. Now, moving next. The precipitate is filtered and the filtrate contains 2 compounds C and D. So we are talking about this C and D. So we have to decide that among these 2 compounds, which is C and which is D. So the compound C is removed by crystallization, and when CO2 is passed through the mother liquor, left D, right? So from here we got that this compound will be D. So now we have decided that C means this is borax. On decreasing the temperature, borax will form in the will come out in the form of crystal, and this is D. So borax is C and this is D. Now we'll discuss about the reaction participating in this. The compound C is removed by crystallization, and when CO2 is passed through the mother liquor, left D changes to C. Now I am writing this reaction. Second reaction is carbon dioxide. So 4 times of NaBO2 plus CO2 will form Na2B4O7. So 10 here and 10 here. So I think this is the balanced reaction, but logic you understand, right? So what is the logic we are discussing is important here. So this is the second reaction. Now moving to the third reaction. In the third reaction, they are saying that the compound C is borax, on a strong heating gives 2 compound D and E. So we can write that Na2B4O7. On a strong heating, they will form NaBO2, 2 molecules plus 1 molecule of B2O3. So among these 3, we have to find which is D and which is E. So E on heating with cobalt oxide. So E is B2O3. So definitely this D is NaBO2. So E on heating. So let me write the fourth reaction. E on heating with cobalt second oxide. So I can write that E is B2O3, and B2O3 on heating with cobalt oxide, there is formation of CO, BO twice, whole twice. and this is blue in color, right? So you can check that reaction is balanced: 2 boron atoms, 4 oxygen atoms, cobalt atom, right? This is the reaction. And this compound is known as F compound, which is blue in color in oxidizing as well as reducing flame. Right, next question, find A to E. So borax on heating, we know that when we heat borax, we are going to get two compounds. So those compound should be NaBO2 and B2O3, NaBO2 and B2O3. We have to check that this compound A is what among these two, right? So on heating borax, we are going to get A. A may be this compound or that compound, we don't know. So now they are saying A is reacting with acid. So B2O3 is a acid oxide. Acid oxide cannot react with acid. So it means that A is NaBO2. So when this NaBO2 is reacting, now I can write that this is NaBO2. When NaBO2 will react, there is a formation of NaCl, and that HBO2 metaboric acid will form. HBO2 metaboric acid will be B. B is reacting with water. We know that from boric acid, if we remove one water molecule, metaboric acid will form. So if we add one water molecule to this metaboric acid, boric acid will form. So C should be H3BO3. Then on heating this C, if we heat boric acid H3BO3, then its anhydride will form, that is B2O3, and water molecule will go away. Now this B2O3, when treated with magnesium oxide, this is a redox reaction. There is formation of boron, which is they have mentioned, and this magnesium will combine with oxygen to form magnesium oxide. So these are the compounds. A is sodium metaborate, then B is HBO2, then C is boric acid, and D is boron sesquioxide, and E is magnesium oxide. Now we are going to discuss about diboron. Basically our purpose is to study diboron, but here we are starting with boron hydrides because so many like alkanes, these are boranes, right? You know that alkane formula, general formula of hydrocarbons, right? CH4. Here also many hydrocarbons type of things are there, which are known as boranes. So boron hydrides we are discussing. Boron forms large number of hydrides called boranes. All hydrides fall into two series. The first series is BnH n plus 4, and the second series is BnH n plus 6. So this is known as nidoborane. This series is known as nidoborane, and this series is known as arcanoborane. So these names are not important according to our syllabus, but you should know that diborane will obtain when n is equal to 2. If I put here n is equal to 2, then it will be B2H6. So diborane is a type of nidoborane, right? It is a type of nidoborane. And we know the structure of diborane, and we have discussed that how many maximum number of atoms lie in a plane. So the maximum number of atoms lying in the plane is 6, right? And we have also discussed that this boron is sp3 hybridized, and in this one sp3 hybridized orbital is vacant, which is for this boron atom, this is participating in this 3-centered 2-electron bond. For this boron atom, this is vacant. So in the whole molecule, there are 2 vacant sp3 hybridized orbitals participating in bonding of diborane. Method of preparation of diborane. So the first method of preparation is by action of lithium hydride or sodium hydride on BF3. So first focus on balancing of this reaction. This reaction is given BF3, LiH, B2H6 and LiBF4. So how to balance it is a redox reaction. How to balance it? First we are focusing on that. So we know that in BF3 this boron is present in +3 oxidation state, and in B2H6 boron is present in -3 oxidation state. So boron is changing its oxidation number from +3 to -3, but there is only one boron atom. So it is taking 6 electrons. So X factor of this whole BF3 molecule is 6. In lithium hydride, lithium plus and H minus, hydrogen is present in -1 oxidation state. So from -1 oxidation state here, it is going to +1 oxidation state. In B2H6, all the hydrogen atoms are in +1 oxidation state. So it is losing 2 electrons. So X factor of this whole lithium is not changing its oxidation number. So X factor of this molecule will be 2. So in order to balance it, what we'll do that we'll find the simplest ratio and then we'll cross multiply. So when we'll cross multiply, in order to balance the number of electrons, I should multiply here by 3. By doing so, the first step is we should balance those atoms whose oxidation number is changing. Here I have already fixed this. Its coefficient is 1. I cannot change here. So I have to multiply half in order to balance this boron atom. So this boron atom is balanced. Now this hydrogen atom is here. And there are 3 hydrogen atoms here. Here also 3 hydrogen atoms. So first step is completed. We have balanced those atoms whose oxidation number is changing. Now we have to balance those whose oxidation number is not changing. So here lithium is 3 and lithium is there. So yeah, I will multiply here by 3. By doing that, there is boron atoms whose oxidation number is not changing. Here also plus 3 and here in this also this boron is in plus 3 oxidation state. So in order to balance these boron atoms, I have to add 3 more. So finally, this will become 4. Right? So boron atom is balanced. Fluorine atoms is balanced, lithium atoms is balanced, and hydrogen atom is balanced. And now if you want to convert into integer, you can multiply the whole thing by 2 and you will get this equation, right? So I think this is the first focus, that how to balance this reaction. Now we'll think that how this product can, we can predict that how it is going to form, right? So mechanism. So here what is happening, that it is a type of substitution reaction, right? This is electron deficient BF3, and this is a nucleophile because it contains lithium plus and H minus, which can act like a nucleophile. So what is happening, that this nucleophile is making a bond or attacking on vacant p orbital of boron, and there is a formation of this intermediate. So because of that, this will form Li plus and BH F3 minus. Now what will happen, that another BF3 molecule will come, and when this molecule will come, what it is electron deficient, so there is a breaking of bond and there is a removal of this nucleophile F minus right here, and there is again formation of BF4. So after that, when this is BF4 minus, this lithium will combine with that to form LiBF4 minus. But this is now converted into BHF2, right? Again, it is an electron deficient substance. So again, this molecule will react with lithium hydride, and this nucleophile will again attack on the vacant orbital of boron. And again, there is a formation of this reaction intermediate. And then there is removal of this fluorine, right? So it is a substitution. This nucleophile F minus is coming. So this nucleophile is substituted by this nucleophile. So finally, these steps are going on, and finally this will become BH3. So BH3, one molecule, and again same steps are repeated to form another molecule of BH3. So 2 molecules of BH3 will combine to form B2H6. So it is a type of nucleophilic substitution reaction where H minus is F minus is substituted by H minus, right? So here we can discuss that what is happening, that F minus is substituted by H minus, there is formation of BH3, and BH3 will combine to form B2H6. And during this, there is formation of LiBF4, which we can see in the mechanism. Here, there is formation of one LiBF4. Then here, there is a formation of another LiBF4, right? So we have written that when one BH3 molecule is forming, there is formation, there is use of 3 lithium hydride particles, 4 BF3 particles, there is formation of 3 particles of LiBF4, right? And there is formation of 1 particle of BH3. I think this is LiBF4, not BH4. This is LiBF4. So in this way, this is the mechanism to predict what are the product formed. The second method is by action of BCl3 on lithium aluminium hydride. So we know that again, this is a substitution type of reaction, because here this lithium aluminium hydride is going to give H minus. It is a nucleophile, and this Cl minus will remove. So it is nucleophilic substitution reaction. Again, mechanism is same, that what is happening, that H minus will come, so there is a formation of BH3 molecule. So here by mechanism we have shown that there is a formation of one BH3 molecule, and there is a formation of BH3, and BH3 will combine to form B2H6, and lithium will combine with chlorine to form lithium chloride, aluminium will combine with chlorine to form aluminium chloride. Now focus on balancing of this reaction, right? So if we balance this reaction, boron here is present in +3 oxidation state, and boron here is present in -3 oxidation state. So X factor of this BCl3 will be 6. Chlorine is not changing its oxidation number, right? Lithium aluminium hydride. So in lithium aluminium hydride, these hydrogen atoms are present in -1 oxidation state. So there are 4 hydrogen atom in -1. All of them from -1 is moving to +1. So 4 hydrogen atoms from -1 to +1, each is losing 2 electrons. So 4 will lose 8 electrons. So X factor of this will be 8. So if I have to balance this reaction, X factor of this will be 3, X factor of this will be 4. I should multiply here by 4, here by 3. Now we'll balance those atoms whose oxidation number is changing. That is boron, boron 4 here. So I will multiply here by 2. Then we'll balance hydrogen atoms, 12 here, and hydrogen atoms is already balanced. So we have balanced those atoms whose oxidation number is changing. Now we have to balance those whose oxidation number is not changing. Lithium 3 here, so I should multiply here by 3, and aluminium should be multiplied here by 3. So lithium and aluminium is balanced. We should check about chlorine. Chlorine is not changing its oxidation number. So here 9 plus 3 is 12, and here it is 12. So this is the balanced reaction which is written here, right? So this is again nucleophilic substitution reaction. The third method is lab method, oxidation of sodium borohydride by iodine. So it is a redox method. So the important point is in sodium borohydride, like in lithium aluminium hydride, all the hydrogen atoms are in -1, but in sodium borohydride, it is formed by reaction of NaH and BH3. So this is Na plus and BH4 minus. So it is a mixture of BH3 and H minus. This is the nucleophile. Only one hydrogen atom is there in -1 oxidation state. All the 3 are in present in +1 oxidation state. So when hydrogen gas here will form, here is also +1 oxidation state. So the X factor of this is important. X factor of this is 1, because only one hydrogen atom is in -1 going to 0 oxidation state. So X factor is 1. For iodine, it is moving from 0 to -1. There are 2 iodine atoms, so X factor will be 2. So we are cross multiplying 2 and 1. So now we have to balance those atoms whose oxidation number is changing. So only one hydrogen atom here. So be careful. I should write here half. And there are 2 iodine atoms, so that iodine atom is balanced. And now we can check that the reaction is balanced or not. I think that reaction is balanced, right? So this is the important point here, that in NaBH4, all the hydrogen atom are not in -1. Only one hydrogen atom is in -1, and it is participating in oxidation. Reactions of diborane. So the first reaction is hydrolysis of diborane, right? So when we are discussing hydrolysis of diborane with water, water is acting like a nucleophile, right? So what is happening, that it is a type of addition elimination reaction. So but this reaction is very fast, so there is no proof of this reaction intermediate. But in general, when we are discussing, we know that when B2H6 is going to react with a nucleophile, there are 2 types of splitting of this B2H6. One is known as symmetric and the other is known as asymmetric, right? So we are going to discuss in coming examples that how it is going to take place. But here we can understand that what is happening, that one water molecule will go, and this first step is there is breaking of this bond, and because of breaking of this bond, right, we can understand the structure of diborane. In diborane, we can draw that this is the structure of diborane. This is the bond like this. So what is happening, that the nucleophile water molecule will go and attach here, and what is happening, that this bridging 3 center 2 electron will break, and there is no electron of boron over here, right? So these 2 electrons will be here, right? So this is only this bond will break, and there is formation of another bond with this boron and water molecule, and because this oxygen is giving electron to this, so it has positive charge, right? So there is a formation of this here. There is breaking of this bond, and now you can see like this. Now what is happening, that this is the first step of opening of the first bridge bond, right? Then the second, because asymmetric may on the same atom again it is going to attach, right? So this is asymmetric addition. So when this addition is taking place, what is happening, that addition of water molecule and then removal of hydrogen molecule from here. So I'm just talking that how the product is going to form. This is the logic, that addition and elimination type of thing is going to happen. There are 6 hydrogen atoms attached to these boron atoms. All these 6 hydrogen atoms are replaced by OH group, 6 OH group, right? So, and this bond will break and there is formation of 2 molecules of boric acid. So I can remember logically that I can consider that for one hydrogen atom, when one water molecule will go and attach to it, there is a removal of hydrogen molecule and there is an addition of OH group to this boron atom. So there are 3 hydrogen atoms attached to this boron atom. So finally what will happen, that this boron atom is attached with 3 OH group and there is removal of 3 hydrogen molecule corresponding to that, right? And same way for this. So total hydrogen molecules eliminated is 6. So this mechanism is not given, right? It is just an, because it is a fast reaction, intermediate cannot be detected. So there is no mechanism available in book, but that is a way to explain, because this is a highly exothermic reaction. So hydrolysis of diborane, we can remember that there is addition of OH group and elimination of hydrogen. So 6 OH group is added and 6 hydrogen molecules will be eliminated, right? So this is the product. This reaction is also, there are many compounds which will give this type of reaction, like reaction of diborane with alcohol will have the similar type of product. Here in place of OH, OR will form and there is liberation of hydrogen gas, addition elimination type of reaction. Reaction with KOH solutions. Okay, so let me explain this. So diborane, it is taking place in aqueous medium because KOH aqueous medium mein hai. So when this diborane is added to water, we have written the reaction, that what is happening. Diborane water se react karke 2 molecules of boric acid or hydrogen gas liberate ho raha hai. Now this boric acid is going to react with base, right? So acid and base will react to form salt. So 2 molecules of boric acid will react with 2 molecules of base to form this salt, right? And this salt, because this reaction is highly exothermic reaction, so it is liberating a lot amount of heat energy. Because of that, इससे हम water molecule निकाल रहे हैं. KBOH4 में से एक molecule में से 2 water molecule निकालो. So 2 molecules में से 4 water molecule निकालो, right? So that's why we are doing that, and then we are writing the product. So you can see here that 2 molecules of boric acid will cancel out. ये salt के molecules cancel out हो जाएंगे. So finally what is happening, that B2H6 is reacting with 6 molecules of water to form 2 molecules of KBO2 and this 4 water molecule and 6 water molecule, 2 molecules on the left hand side, and there is formation of 6 molecules of hydrogen. So that is a way to explain that ये product है, इसको हम KBO2 को कैसे logically समझाएंगे. डाइबोरेन वाटर से रिएक्ट करके बोरिक एसिड के 2 मॉलिक्यूल बनाएगा. बोरिक एसिड इज रिएक्टिंग टू फॉर्म सॉल्ट, क्योंकि इट इज हाईली एक्सोथर्मिक रिएक्शन. उस सॉल्ट से वाटर मॉलिक्यूल निकाल दो तो ये पोटेशियम मेटाबोरेट विल फॉर्म, राइट, एंड हाइड्रोजन गैस इज लिबरेटेड. मूविंग टू दिस इज वेरी इंपॉर्टेंट, इस पे जेईई एडवांस में क्वेश्चन पूछा गया था, क्लीवेज रिएक्शंस ऑफ डाइबोरेन. सो जब भी ये डाइबोरेन न्यूक्लियोफाइल की प्रेजेंस में रिएक्ट करता है, इट विल रिएक्ट इन 2 स्टेप. सो द फर्स्ट स्टेप इज कि पहला जो ब्रिज बॉन्ड है वो ब्रेक हो जाएगा और जो न्यूक्लियोफाइल है वो किसी भी एक बोरोन एटम से अटैच हो जाएगा. सो हियर हमने क्या किया कि ये हाइड्रोजन और ये बोरोन इसी के हैं ना, इन दोनों के, तो ये पूरा शिफ्ट कर दिया. इसका कोई इलेक्ट्रॉन नहीं था तो इस पर कोई चार्ज डेवलप नहीं हुआ, ये बॉन्ड ऐसे शिफ्ट हो गया. और ये जो न्यूक्लियोफाइल है इस इलेक्ट्रो डिफिशिएंट बोरोन एटम से आके इसने कोवेलेंट कोऑर्डिनेट बॉन्ड बना लिया. सो दिस इज द फर्स्ट स्टेप which is happening with all nucleophile. There is no difference in that. But the second step is important. There are 2 possibility in second step. ये जो दूसरा वाला टूटेगा उसमें 2 possibility हैं. So the less bulky molecules like ammonia, water, methylamine, dimethylamine, and this compound dimethyl sulfur oxide, right? Whatever this compound is there, इनमें क्या है कि ये लेस बल्की ग्रुप में, तो लेस बल्की ग्रुप में एसिमेट्रिक क्लीवेज है. एसिमेट्रिक का मतलब हो गया कि देयर इज डेवलपमेंट ऑफ चार्ज. जिस बोरोन एटम पे पहले अटैक हुआ था उसी बोरोन एटम पे अभी भी अटैक होगा, राइट? सो व्हाट इज हैपनिंग हियर दैट ये जो बोरोन एटम पे पहले से इक्विवेलेंट कोऑर्डिनेट बॉन्ड बना था, अब ये न्यूक्लियोफाइल अगेन आके इसी पे अटैक कर रहा है. एंड नाउ वी कैन सी हियर दैट कि ये वाला बोरोन का इलेक्ट्रॉन ये था, अभी इस वाले बॉन्ड में दिस बोरोन हैज नो इलेक्ट्रॉन, राइट? तो ये इलेक्ट्रॉन इस बोरोन एटम का है. सो व्हाट वी आर डूइंग हियर दैट कि जब ये न्यूक्लियोफाइल यहां जाके अटैक करेगा एंड देयर इज फॉर्मेशन ऑफ कोवेलेंट कोऑर्डिनेट बॉन्ड ओवर हियर, ये बॉन्ड ब्रेक होगा और ये बोरोन अपना इलेक्ट्रॉन इस बोरोन को देगा. तो इस बोरोन पे नेगेटिव चार्ज डेवलप हो गया BH4-, और इस बोरोन ने इलेक्ट्रॉन दिया तो इसमें पॉजिटिव चार्ज आया था ना. अब ये कोवेलेंट कोऑर्डिनेट बॉन्ड बनाया और इस पे पॉजिटिव चार्ज आया हुआ है. दिस इज देयर, राइट? सो दिस इज द कंपाउंड व्हिच इज गोइंग टू फॉर्म. सो इसको कहते हैं एसिमेट्रिक क्लीवेज. ऑन एसिमेट्रिक क्लीवेज देयर इज फॉर्मेशन ऑफ आयनिक कंपाउंड and the nucleophile will attack at the same place 2 times. Now more bulky molecules, दूसरा केस समझते हैं. More bulky molecules like methyl trimethylamine or this is ether, dimethyl ether will give symmetric cleavage. So in symmetric cleavage there is no development of charge. एक molecule से एक nucleophile और दूसरे molecule से दूसरा nucleophile. So this is the structure over here, right? So दो अलग अलग बोरोन एटम से ये न्यूक्लियोफाइल आके अटैच होगा and there is formation of this. So fourth type of reaction of diborane with ammonia followed by heating to form inorganic benzene. So this is very important reaction and now you can see that ammonia, water, ये सब क्या है? They are less bulky group. So less bulky group में क्या होगा? एक ही बोरोन एटम पे दो बार अटैक होगा. So that they have formed here कि ये बोरोन एटम है और इस बोरोन एटम से दो कोवेलेंट कोऑर्डिनेट बॉन्ड ये अमोनिया ड्रॉ बना रहा है एंड देयर इज प्लस चार्ज ऑन दिस. और ये जो दूसरा वाला हाइड्रोजन बोरोन था उस पे सारे हाइड्रोजन एटम अटैच हो गए लाइक दैट. We have discussed like this, right? BH4-. So this is happening because ammonia is the less bulky group. So asymmetric cleavage will take place. और अगर हम इसको हीट करते हैं तो from 3 molecules of this ionic compound there is removal of hydrogen gas and there is formation of inorganic benzene. ये बेंजीन जैसा एरोमेटिक होता है, प्लेनर होता है, थोड़ा सा ये पोलर होता है. बोरोन नाइट्रोजन की इलेक्ट्रोनेगेटिविटी डिफरेंट है इसलिए ये पोलर होता है. Otherwise it is a liquid also like benzene and we can say that जैसे बेंजीन में 6 कार्बन एटम होते हैं वहां यहाँ पे 3-3 बोरोन और नाइट्रोजन एटम है. And if you draw the structure, this nitrogen has positive charge and this boron has negative charge, right? So polarity होती है, इसकी वजह से ये थोड़ा ज्यादा reactive होते हैं with respect to benzene, right? So moving to fifth reaction of diborane with methanol. This is same as that of water. वाटर में क्या होता था कि ये जो 6 हाइड्रोजन एटम है वहां OH ग्रुप अटैच हो जाते थे, तो 2 मॉलिक्यूल्स ऑफ बोरिक एसिड, यहाँ पे 2 मॉलिक्यूल्स ऑफ बोरिक एसिड की जगह OH की जगह OMe ग्रुप. सो सेम कॉन्सेप्ट, एडिशन एलिमिनेशन टाइप ऑफ रिएक्शन विथ वाटर. और hydrogen gas is removed, so it is addition elimination type of reaction. Other reactions is ये तो हो गया combustion, जैसे CH4 का combustion होता है तो CO2 बनता है और water बनता है, यहाँ पे B2O3 और H2O बनेगा and this is highly exothermic reaction. Again this reaction is given in NCERT and it is acting like a very good fuel. A lot amount of heat energy is liberated. B2H6 ये एक न्यूक्लियोफाइल से अटैक कर रहा है और ये एक तरह से लेस बल्की ग्रुप है, राइट? बट ये हाइड्रोजन ही है तो इससे कुछ होगा नहीं. देयर इज फॉर्मेशन ऑफ BH4-, राइट? LiBH4, राइट? सो B2H6 रिएक्टिंग विद Cl2, इसमें भी एडिशन एलिमिनेशन है कि हाइड्रोजन हटेगा, क्लोरीन जाएगा और हाइड्रोजन और क्लोरीन आपस में कंबाइन होकर HCl. So hydrogen is substituted here. 2 boron atoms, 2 molecules of BCl3 and 6 molecules of HCl gas. Now let us practice some questions. What we have, ये JEE Advanced 2009 में क्वेश्चन पूछा गया. 2x plus B2H6 डाइबोरेन की रिएक्शन 2X से X के बारे में पूछा जा रहा है. द अमीन्स आर, मतलब X तो न्यूक्लियोफाइल ही है, and they are forming ये ionic type of compound, means asymmetric cleavage, and this asymmetric cleavage will come with less bulky group. So these are the less bulky group, right? ये more bulky है जिसमें symmetric आएगा. So the answer will be A, B, C. The number of water molecules required to complete hydrolyze one molecule of B2H6 कैसे याद रखेंगे? हमें पता है कि ये B2H6 का मॉलिक्यूल है और ये एडिशन एलिमिनेशन टाइप ऑफ रिएक्शन है, तो 6 वाटर मॉलिक्यूल ऐड करने पड़ेंगे, एंड बिकॉज ऑफ दिस 6 वाटर मॉलिक्यूल देयर इज फॉर्मेशन ऑफ 2 मॉलिक्यूल्स ऑफ बोरिक एसिड and there is removal of 6 molecules of hydrogen. This is the reaction, right? So they are asking the number of molecules of water required to react, that is equal to 6. In borax, the number of boron atoms having sp3 hybridization is, अगर आपको बोरेक्स का स्ट्रक्चर याद है, Na2B4O5OH4.8H2O, इसका जो एनायन है, इसका अगर मैं स्ट्रक्चर ड्रॉ करूं तो देयर आर 4 बोरोन एटम्स. ये चारों बोरोन एटम्स आपस में BOB बॉन्ड से अटैच होंगे और 2 बोरोन एटम जो है एक एक्स्ट्रा BOB बॉन्ड से अटैच होंगे. तो जो एक्स्ट्रा BOB बॉन्ड से अटैच होंगे उस पे एक नेगेटिव चार्ज होगा. दे आर टेट्राहेड्रल यूनिट, और जो टेट्राहेड्रल यूनिट्स हैं उनका हाइब्रिडाइजेशन हमें पता है, they are sp3 hybridized. So 2 boron atoms are sp3 hybridized and 2 boron atoms are sp2 hybridized. ये भी पूछा जा सकता है इसमें कि ये जो एनायन है या पूरा मॉलिक्यूल है, इसमें कितने 6 मेंबर्ड रिंग है. तो ये एक 6 मेंबर्ड रिंग है और ये दूसरी एक 6 मेंबर्ड रिंग है. देयर आर 2 6 मेंबर्ड रिंग इन बोरेक्स. बोरोन हाइड्राइड आर कॉल्ड बोरेन्स. अभी हमने पढ़ा था नीडो बोरेन्स एंड आर्कैनो बोरेन्स. There exists 2 series of boranes. One is BnHn+4. ये जो है वो नीडो बोरेन है, इसको हम कहते हैं नीडो बोरेन. और जो अदर है उसको हम कहते हैं आर्कैनो बोरेन. और हमने ये पढ़ा कि नीडो B2H6 जो है वो नीडो बोरेन का एग्जाम्पल है, और आर्कैनो बोरेन में फॉर्मूला होता है BnHn+6. तो दे आर आस्किंग कि व्हाट इज द वैल्यू ऑफ X. So that is equal to 6. Diborane is reacting with ammonia to form this reaction intermediate, which on heating will liberate hydrogen gas and form inorganic benzene. तो अभी अगर मैं X की बात करूं, क्योंकि यहाँ पे अमोनिया जो है वो लेस बल्की ग्रुप है, सो एसिमेट्रिक क्लीवेज होगा. सो देयर इज अ फॉर्मेशन ऑफ एन आयनिक कंपाउंड. तो मैं उस आयनिक कंपाउंड को लिख देता हूं कि एक ही बोरोन एटम से 2 अमोनिया मॉलिक्यूल्स आके अटैच होंगे. एक ही बोरोन से 2 अमोनिया और 2 हाइड्रोजन ऑलरेडी है यहाँ पे, तो इस पे पॉजिटिव चार्ज आएगा. और दूसरे वाले में BH4-. सो दिस इज गोइंग टू फॉर्म, राइट, दिस इज X इंटरमीडिएट, और इसलिए इसके 3 मॉलिक्यूल्स जब हीट करेंगे तो देयर इज फॉर्मेशन ऑफ इनऑर्गेनिक बेंजीन. ये जो है वो है B3N3H6 inorganic benzene. But they are asking that in the anionic part of intermediate X, the covalency of central atom boron is this and the covalency of this is 4. 4 covalent bond बन रहे हैं, ठीक है. So covalency will be 4. So the answer of this question will be 4. So hopefully this is useful to you. So we are doing a lot of hard work, and we want that you should tell the other people that this channel is good and the things on this channel is good for JEE mains and advanced. Thank you very much.